pulsing object in space is unlike anything we have seen before. Astronomers say astronomers have detected an astonishing celestial object emitting bright flashes of radio waves and X-rays that last for 2 minutes and repeat every 44 minutes. In a fresh twist, the discovery marks the first time powerful X-rays have been associated with an object that might be a long-period transient. Astronomers first spotted this cryptic new class of objects in 2022, and fewer than a dozen have been found so far. Long-period radio transients (LPTs) are a recently identified class of cosmic objects that emit bright flashes of radio waves every few minutes to several hours, said Dr. Andy Wong, an associate lecturer at the Curtin Institute of Radio Astronomy in Australia, in an email. What these objects are, and how they generate their unusual signals, remain a mystery. The object, named ASK APJ1832911, is located about 15,000 light-years from Earth in the same galaxy as our solar system. The X-ray emissions, uncovered by NASA's Chandra X-ray Observatory, could be the key to helping astronomers understand more about the true nature of these intriguing cosmic objects and their pulsing behavior. X-rays usually come from extremely hot and energetic environments, so their presence suggests that something dramatic happened to the object, said Wong, lead author of a study reporting the observations, which was published Wednesday in the journal Nature. The long-period transients appear to be more energetic than previously believed if they can produce X-rays, which have more energy than radio waves, Wong said. A cosmic enigma now, researchers are trying to figure out the source of ASCAP J1832911's radio waves and X-rays, which don't fit into a neat box for categorization, and whether it's truly representative of a long-period transient or an eccentric outlier. At first, the team thought the object might be a magnetar, or the dense remnant of a star with an extremely powerful magnetic field, or a pair of stars that includes a highly magnetized dead star called a white dwarf. But neither of those quite matched up with the bright and variable emissions of radio waves and X-rays, the researchers said. This object is unlike anything we have seen before, Wong said. Even those theories do not fully explain what we are observing. This discovery could indicate a new type of physics or new models of stellar evolution. Astronomers traced a previous detection of a long-period transient, announced in March, to a white dwarf that's closely orbiting a small, cool red dwarf star. The two stars orbit each other so closely that their magnetic fields interact, emitting long radio bursts. In that study, researchers detected signals in visible and infrared light that corresponded with the signals they observed, suggesting they could belong to two different types of objects. Wang's team made no such observations of ASCAP J1832911, he said. Charlie Kilpatrick, co-author of the March study, called the new find exciting. He did not participate in the new research. The nature of this source bridges the gap between the most extreme magnetars and white dwarfs, which is telling us just how extreme these compact objects can be, wrote Kilpatrick, research assistant professor at Northwestern University's Center for Interdisciplinary Exploration and Research in Astrophysics in Illinois, in an email. Wong said future X-ray observations may reveal more about the object, such as its temperature and size, which researchers could use to determine the source. But the new detections are already changing the way Wong and his collaborators think about long-period transient signals. A chance detection radio astronomers regularly scan the sky using the Australian Square Kilometre Array Pathfinder, or ASKP. Located in Wayari Yamaji country in Western Australia and operated by Australia's Commonwealth Scientific and Industrial Research Organisation, or CSIRO, Wong and his collaborators first picked up on a bright signal from the object in December 2023. Then, the object released extremely bright pulses of radio waves in February 2024. Fewer than 30 known objects in the sky have ever reached such brightness in radio waves, Wong said. By coincidence, the Chandra X-ray Observatory was pointing at something else, but it happened to catch X-ray observations of the crazy bright phase of the long-period transient, Wong said. Discovering that ASCAP J1832911 was emitting X-rays felt like finding a needle in a haystack, Wong said. The ASCAP radio telescope has a wide field view of the night sky, while Chandra observes only a fraction of it. So, it was fortunate that Chandra observed the same area of the night sky at the same time. Unlike rapidly spinning neutron stars called pulsars, which release pulses that last milliseconds to seconds, ASCAP J183-20911 periodically varied in radio wave and X-ray intensity every 44 minutes. The object also dropped off in X-ray and radio wave intensity. Observations taken by Chandra 6 months later, in August 2024, showed no X-rays. The team also used the CROCO, or Coherent Radio Astronomy Core, instrument, which was recently developed to detect mysterious fast radio bursts, or millisecond-long flashes of radio waves, and other celestial phenomena. The instrument can rapidly scan and process data to spot bursts and zero in on their location. That's the equivalent of sifting through a whole beach of sand to look for a single 5-cent coin every minute, said Dr. Keith Bannister, a CSIRO astronomer and engineer who helped develop the instrument. But CROCO is also able to detect long radio pulses and help the team determine that the bursts of radio waves were repeating. Other observations showed that the X-rays were repeating as well. Data from telescopes in the United States, South Africa and India and collaborators from around the world made the extremely rare detection a truly global effort, Wang said. Moving forward, Wang and his team will continue searching for more objects emitting these long radio pulses. Finding one such object hints at the existence of many more, said study co-author Dr. Nanda Ria, a professor at the Institute of Space Science and the Institute of Space Studies of Catalonia in Spain, in a statement. The discovery of its transient X-ray emission opens fresh insights into their mysterious nature.